Hello, everybody. I'm really glad to see you all here today. I'm Filipe, and I'm here to talk about Ecto, Postgres, and how to speed up queries using those. So in Fresha, I'm a software engineer at Fresha, and we work with a lot of data there. So just for so you have an idea, like one of the services that we own, that my team owns, generates around 10 million of landing pages a day, and those landing pages are generated based on Postgres and queries from Postgres. And when you work with a lot of data like that, performance is really important, right? Like query performance is really important, and was one of the things that we have to most pay attention to. So my goal here today is to share a bit of my experience working with optimizing queries, and give you the most important tips I think they're the most important ones. So I'm assuming that most of you here know what Ecto is, but for those who might not, so textbook definition of Ecto is, it says, it's a toolkit for data mapping and language integrated query for Elixir. In simple terms, what I think that really means is, it's a library to interface with the data layer. So it's split in 4 modules, as you can see on the slide over there. And when I say data layer, I mean that it could be actually any kind of data layer. It doesn't necessarily have to be SQL databases, but the most common case is with SQL databases, so this is what we're going to talk about here. So Ecto is just the interface, right? The thing to interface with the data layer. And then you have another library called EctoSQL that actually talks to the database engines and do the more complicated bits of interacting with databases. By default, it comes with those 3, like SQL Server, MySQL, and Postgres adapters on EctoSQL. So in this talk, we're going to focus on those 3 modules, because we're going to focus only on reading. We're not going to really talk a lot about writes here. And we're also going to talk a lot about EctoSQL, specifically the Postgres integration. So I'm going to talk a lot about that and about Postgres. Does that mean I just tricked everybody here into listening to a Postgres talk, thinking it's an Ecto talk? Well, yes, but I think that's a good thing, because that means that, to me, that means that Ecto is such a thin abstraction on top of the database, on top of any SQL database, in this case Postgres, that a lot of the optimizations we'll end up having to make, they are database optimizations, which usually are the things that are most complicated, and they give you the more advantage. And so let's get started. So I want to start talking about the query plan. Who here knows what a query plan is? There is a lot of people. I'm going to explain anyway. So a query plan, in simple terms, is a set of instructions that describe how the database is going to execute the query. So SQL is a declarative language by default, and the query plan is something made that the query planner, which is implemented by each database engine, creates, that turns those declarative statements into imperative instructions. And they are the single most important thing you need to pay attention when you're going to optimize any query. Looking at the query plan is the first thing you should be looking at, for any case. So this is what the query plan looks like, just like a bit of a spoiler. But let's not get ahead of ourselves, because before we talk about going deep into the query plan, I want to talk about how to get the query plan. One way you can get to the query plan is to extract your SQL query from your Ecto query. So let's say you have this Ecto query here. It's a very simple one. So selecting from the location table, joining the provider table by the foreign key provider ID, and filtering by country code. To get the plain SQL out of this query here, I think the simplest way is just to change the logger level to debug. So the logger level is something that can be changed either in the configuration file, or you can do it imperatively like that, just calling the function on the logger like I just did there. And by default, it's set to the level is warning or errors, which is only going to log warning or errors. But when you set them to debug, every query that you run in your system is going to be logged into the console for you. And that works really well, like if you just want to do it in isolation, which I think you should, like you want to do it in a test case. I mean, let's say you have a test case, you have a query that's being slow, you want to get the SQL, the plain SQL from that, you can just add this to the test case, and it's going to start printing the query for you. You should not leave that by default in your configuration, because it's going to create a lot of logs, and probably the tech ops team is not going to be really happy with you. So if you do that, you're going to print your SQL query, which is something like this. Like this is like, you see, like they're very similar. That's what I say. Like Ecto is very close to SQL, right? So they're almost the same. You're going to have like something similar to this. And with the plain query, you can run explain, analyze. So a lot of people think that explain, analyze, they're the same thing, but they're not really. The actual command is explain, and analyze is a parameter of the explain command. But they usually are used in, together, so that's why there is this confusion. But the main difference is explain is going to give you the actual query plan. It's going to give you the instructions that the set of instructions that I talked about. And analyze is going to analyze each of those instructions and run some statistics on it. It's going to tell you how much time it took to run something. It's going to give you some idea of resource used and stuff like that. And another big difference is that if you use only explain, it's going to dry run your query in the database. So it's not going to actually execute the query. But when you put analyze together, it has to execute your query, so it gets the statistics, the timing. So it can be, like if you do that in a production environment, let's say, it can be damaging, resource heavy if your query is very slow. And you should actually do that in a case similar to production, because the data that you have in the database is going to affect how the query plan is going to be generated. Like use the statistics of the database to create the query for you. So be mindful to not run a very heavy query in production, let's say, like with explain, analyze, that might affect performance. Another way to get the query plan is to just call the explain function in the repo. So the explain function is you're just going to pass the function from the repo function that you want to explain, the query itself, and the parameters. It works really well with Postgres because Ecto supports most of the Postgres options. So in this, see here like how analyze is very easy, and you can pass like there is a lot of stuff you can pass here, and I'm not going to go into those now, but just let you know that it has a very good support with Postgres. So there you go, the query plan again. So either if you do through getting the plain SQL or running explain in repo, that's what you're going to get. This is the query plan. But it's not really readable, right? It's not very easy to parse what's going on here. It's just a big blob of text. And that was a very simple query, and already the output was something like this. So if the query is bigger, it's going to be even more complicated. That's why I recommend using some kind of visualization tool like Dabble. Dabble is the one I use, but there is like a lot of them on the internet. You can use whatever, they're pretty similar. And with that, you can have a much better understanding of what are those instructions that the query plan is explaining. Yeah, so you can see that now it's much easier to understand. And how you should read this is bottom to top. So the bottom nodes, they are the ones that are being executed first, then goes up to the top. In this case here, we have an index scan on the providers table, which means you use an index to get the data from the providers. You have a sequential scan for the locations table, which means it ran over all the entries of the locations table to get the data needed, and the nested loop to do the join. Again, this can go very deep, and I could give a whole talk about how things to look out here, like what to interpret, like the tips and stuff like that. But I just want to focus on I think one of the most common things that can happen, the most common thing that's going to help you in a lot of cases, which is paying attention to the nodes that take more time. In this case, you can see was the sequential scan that took 14 milliseconds, and pay attention to nodes that are filtering out a lot of data. So what did this sequential scan do? You can see there it says rows removed by filter, 45,000. So it means that went over 45,000 rows to return only 200 rows. So that is a sign that the selectivity is bad, and that when you see stuff like that, like a node that goes to a lot of rows and filter a lot of them out, is usually a very good candidate for an index that's going to speed things up by a lot. talking about indexes. So index is the simplest, most powerful tool you have in a SQL database to speed up your queries. A well-made index can make a world of difference, and they're relatively easy to do. There are trade-offs, of course, but they are the things that's going to help you a lot when you're trying to optimize queries, especially in cases like I just described. So how do they look like, though? Let's take the example here, the service table. So this is a service table that has name, business ID, and price, right? A very simple table. And a service type as well. So when you create your index in Ecto using Ecto migration, you can create your index in your migration using a syntax like that. And when you do that, like in this case, you're going to create an index on service type and price. So Ecto, by default, is going to use the Postgres default, which is a B3 index. That is the, again, most common index that people use, because it covers most of the use case, like search by quality, greater than, lesser than, etc. There are a bunch of other types of indexes, but I'm not going to go into them here now, because that's the most used one. So when you do that, it creates a data structure similar to this. This is obviously a simplification. It's like in reality, it's a bit more complicated than this. But what I want you to take away from this is a few characteristics of the index. So in this case, a BT data structure. The index data is sorted in ascending order. This is really important, both across the pages and inside the page. When I mean page, I mean those square thingies there. It's first going to order the index by the service type, which was the first column, and then by price, which is the second column. Another very important thing is the reference to the table. So those are only like the indexed values, and the reference to the table are held only in the leaf nodes, the ones in the bottom, and each node page, so the ones each page in the middle, they're used only to traverse the tree, and the reference are only held in the leaf ones or the bottom ones. So when you do let's say quality lookup, something like that, service type equals 2, let's see how the index lookup is going to look like. It looks like something like this. So it goes from left to right, top to bottom, and traverses the tree to find all the leaf nodes that match the condition. In this case, service type equals 2. You see, like in the bottom is like finding all the conditions that match the condition we passed on the query right there. So it goes to the leaf nodes, which holds the reference to the table, then goes to the table and fetches the data that you need, right? And again. This only works well, the index only works well because it's sorted. So the sorting is paramount for the index to actually work. Let's do an example now, filtering by service type and by price, less than 400. It's going to be really similar, with the difference is it's going to stop when it reaches the entry there, like the value, which has 700 as a price, which is higher than 400. So it knows that only those in the middle are the ones that are the left to right, are the ones that the index needs to fetch from the table. So that's why it makes it much faster. So let's try now searching only by price. How does that gonna look? It doesn't. Why it doesn't? It doesn't because like when you search by price, remember the ordering is the thing that makes the index work so well. And because the index is sorted first by service type, it can't efficiently find you the price, because the price is you see in the bottom here, is gonna try to, is gonna miss the price value because of how it's it assumes that everything is in order. So if you try to do something like that, Postgres will probably return the data for you. It might even use the index, but it's gonna use it's not gonna use the index in an efficient way. It's not gonna do an index lookup, it's gonna do something, maybe a bitmap index scan, and it's not going to be really efficient. So I said all of that just to make a very simple point, which is the order of the columns when you're creating your index, they matter a lot. They change completely how the indexes work, and they change how the data structure of the index is going to be created. And since we're talking about indexes, I want to give you one tip that a lot of people might not know, that's very easy and can help you a lot, is that you can include values from the database to your index. And when you do that, you avoid going to the database to actually fetch those values. So this is a Postgres feature, but Ecto, again, has a very good support for it. You declare your index there, pass an option called include with the name of the table you want to include, and it's going to look something like this. So all the name column is going to be stored inside the index data structure. And because of that, it doesn't have to, the index doesn't have, when it does the lookup and finds the leaf nodes, it doesn't have to go all the way to the database to fetch the data back for you. And when you do that, like just to have an idea of how powerful it is, in this case here that we're selecting only the values that are within the index, on the left, my left at least, you're right, it's you can see the index scan that took 60 milliseconds and went to fetch the data from the database. And on the index-only scan, which is the one that only uses the index, it took less than 1 millisecond. So it can be really powerful and it can be really helpful to doing some cases where your performance is really, really needed. Now let's talk about querying. So I just talked about how to get index-only scans by using include. And one tip for you not to miss your index-only scans is to be mindful of your queries. So let's take this schema here. So it's a review schema. You have like two reference to the location table, to the appointment table, and you have a bunch of rating reviews related data. And you're going to create your index, something like this, on the location ID and the rating, and you're going to include text and author name. And you want to use your index-only scan, right? If you did include, you're probably aiming for index-only scan. If you do something like that, by default, Ecto is going to translate, is going to map your query to all the columns that are mapped in your schema, because you did not specify a select. And if you select like this, you're going to get only an index scan, because it has to go to the table to fetch all the other columns that you're selecting, even though you might not even use them for your case. So to make sure that you're going to hit your index-only scan, you need to specify the select, which of course is going to map to only the selected fields. And in this case, you're going to get your index-only scan. So just for reference, you should mostly do the select like that in Ecto. In those special cases, like overall, it's okay. It's actually a good practice to just do like the select with all the columns, because it makes the application more consistent. So like you're sure that like your schema struct is going to be fed with, it's going to have like all the columns that you need. But in those special cases, minding the select can make like a total difference. And the last thing I want to talk about here is the N+1 problem. So N+1 problem is a problem that's it can happen in Ecto if you don't pay attention, and there are some ways to avoid that. So to give this example, let's imagine that you work in a beauty and wellness marketplace. And those are some of the tables on your system, right? You have your locations table with some name, like some type, reference to the address in the review. Each of them hold like the information from like a few information from reviews and addresses. And your business just got bought. Your business was doing so well that it got bought, and your new boss comes to you and comes to you and your new boss comes to you, and while he's busy doing important stuff like thinking of a better name for your business, he asks you to do a new API that's going to return all the locations for a given type along with its top 3 reviews. So how does this API going to look like? It's going to look like something like this. So let's say we get locations by type with top reviews, passing the location type. And it expects you to return something like that. So this is going to be a list of locations. Each location has the address information and the top 3 reviews. And yeah, imagine this list is bigger, but it wouldn't fit in my thingy here. So one very naive way of doing this implementation is doing something like that. That first queries the location, and then for each location entry, we're going to run a query to get the address and the top reviews. But if you do that, you're going to have major performance issues. Why? Because let's say you have your first query here, the location query is going to have, I don't know, 100 entries. And then for each of these 100 entries, you need to query 2 times more. So that means that you're going to have 201 queries. So this is what n plus 1 means. When you do n times plus the 1 query that you did because of the because you're just querying for interactively on each one of the rows. One way you can do to mitigate this is using preload in Ecto, which is a built-in feature. And what preload does, Ecto is gonna do for you 3 queries under the hood. So Ecto understands that addresses and reviews, because you associated them on the reviews schema, they have association with the locations table. Sorry, with the location schema. They have association with the locations table. So Ecto is gonna run 1 query for locations, 1 query for all the addresses associated with the location that was returned first, and another query for all the locations that was returned in the first row, or in the first query. And he does that under the hood for you, and maps all this data to the right locations, again under the hood. And you don't really need to do anything. So in this case, you're gonna have 3 queries, which is good, but can be better. To make this better, we can explicitly pass a join statement to the query that we have. So we're gonna do a normal join in the database, and we just pass the binding of our join to the Ecto preload. And that's gonna help Ecto to map. Ecto is only gonna map all the entries on your join, and you're gonna have the total of 1 query, which is awesome, right? So you have like 1 query, you're feeling good, you're getting all the data, and you're just getting the top reviews on the bottom there, like on the post-processing. So you have this, you put to staging, and you show to your boss to see the great work that you just did, but it's not happy. It's not really working, like it's very slow, and it takes a lot of memory in the machine, and you have to fix it, of course, like that's like you can't leave it like that. Can anybody here tell me what is the bottleneck with this code right there? Like what's making it so slow?
You can't sort it. I mean, you can sort it on the database level, and you can get only 3 records from the database.
Exactly, that's exactly right. The problem is the post-processing. Like you're like getting a lot of data, and then you are post-processing like the reviews on the code level, like the application level, and that can be really time-consuming and resource-consuming. What you can do in Ecto as well, again, Postgres feature that had a very good integration for Ecto is doing a lateral join. And lateral join is basically, it works kind of a for loop inside of the database. So it understands you have an outer query, and for each entry of the outer query, the Postgres is gonna do wants to be query like that one there, which you can pass the limit, you can pass the ordering already, and only return the actual data that you need to you're gonna need, like in this case, for the output. And everything, and all of that happens inside the database and without any post-processing. So in this case, so if you do that, you're gonna have 1 query, no post-processing. The lateral join is gonna use the same indexes rule. So if you have an index there, index all in scan and all of that, it's gonna be really fast and it's gonna work. It can really help you out in some cases like this, where you delegate everything to the database and just do it one time. And just to wrap it up, I talked about a bunch of stuff here, but in the end, there is not really one thing that's going to help with all of your problems. Like the best thing you can do to optimize your data model and like to optimize your queries is to understand your data model, understand your use cases, and use those tools to help you fix the problem. So understand exactly what you need to do and try to solve the problem with those. Like the tools are only assistant to you. And that's it. Thank you.
Thank you, Filipe. Do we have any questions for him? Anyone in the audience?
I explained very well then. Good.
Okay. We have one from Huva. And what are some of the trade-offs with adding indices?
Okay. So basically, the biggest trade-off with adding an index is you're going to compromise your writes to optimize your reads. So whenever you add an index, as I showed you, is a data structure that is sorted. And if you change any value of your table that touches the index, or you add a new entry to the table, it needs to reorder the index. It needs to, like, that tree needs to be resorted. So that gives a penalty to writing to the table. And that's usually, this trade-off usually pays off in most cases because the reads are more pressing than writing. But the biggest trade-off is that, like, you're compromising your reads to optimize your writes.